about creating the empty. Okay, I guess.
Go game test might be interesting. Yeah. Okay. So are you familiar with how pair programming works?
No, I'm not familiar.
So the basic idea is that we are both trying to deliver the same product, and so we take turns or we switch every few minutes. When one person is the driver, the other person is basically helping out. So you can start on the keyboard and try to create your vision of what the Go game looks like. We can basically do it together, and we can switch whenever we want to.
Okay.
That makes sense? Okay.
Makes sense.
So just so you know, the way I like to do things when I'm doing TDD is that also I want to make sure that, for example, I like to start with the code very, very clean. So I remove all the usings as well. So I just remove all the unused directives. And also the class name should have a good name here. What should we rename it to?
So I was thinking the first test would probably be interacting with the board directly. So like putting stones on the board. So I maybe like add stone tests.
Add stone tests.
Or are you talking about just with general, so maybe board tests, and then the scenarios would be adding stones?
Well, let's start with what do we want to demo out of this session?
Okay.
What do you want to demo?
What was the issue that I was having problem with? I forgot. Give me a sec. Well, the thing I want to demo out of this is interaction between multiple objects, right? So...
Yeah, but in terms of a deliverable product, what were you trying to accomplish?
Oh, I was trying to accomplish a game that two players can interact with each other, or, well, basically, like, I guess what you call like an engine where I could add in like AI to replace replace a player. But I wanted like a full game for the Go game. Is that what you were asking?
Okay. So we can start with maybe full game tests. See what happens.
Full game tests. Okay.
Yeah. So just F2 on the class name.
Okay.
Full game tests, and that will also rename the file name in the Solution Explorer, which is amazing because Visual Studio still doesn't do that after like 4 or 5 years. I don't know why. Okay. Next, we have to make this a test class. So we have to add NUnit to the package through NuGet.
Okay.
So do you remember how to do that? Just install package NUnit. Now, at first, we're just going to write the tests and the production code in the tests, and then we can refactor them out later. Okay?
Right.
Because the goal of this is to actually produce real code that works. It's not just to have tests. The goal is to... I call it test-driven development because the idea of the test is to drive development.
Right.
So we're going to start with the happy path stuff to get things going so we can demo something so we can get feedback.
Okay.
Okay, so we have NUnit, and now we can add the test fixture attribute and the tests.
I forgot, does the test fixture go on top of the class?
Yes.
What's the shortcut? What's it, Alt-Enter?
Control-Alt-Space if you want to get a nice completion here. Control-Alt-Space.
I did that.
Interesting. Huh.
The things next to it says Alt-Enter.
Yeah, but if you want to have a nice completion of, let's see what the resharper configuration here is. Hold on. Visual Studio, we're using the resharper 2x, which is what I'm used to, and in there...
Maybe I misunderstood. I was supposed to do test... Oh, sorry.
Okay, you write it. Test. Just use the word test. Control-Alt-Space.
I just start testing it and then Control-Alt-T.
Control-Alt-Space.
Control-Alt-Space. All right, how about you give it a try, and let's see if you have a better.
Okay, test fixture, Control Alt Space. No, oh yeah, for me it's a Mac, but you know what? Let's just get rid of this and say fixture and be done with it.
Forget T. There you go.
Oh, there you go. Now we have an Alt Enter here. Apply to all sharper shortcuts. From this moment on, it won't bother us anymore.
Okay.
And we can write our first test.
Hmm.
Okay, so where do you want to start? What should be a good move to start with?
So I mean, from the books I read, like the first test is basically a very easy test, right? So
It should be something that you can. It should be. I call it a unit of work. A unit of work is something that you usually start with a public method, and it ends up with one of three end results. So you can have a value returned. You could have a state change to a system, so the system behaves differently. For example, it used to say X, but then I did an action, now it says Y. Or you call out to a third party, like logging infrastructure.
right.
So, what do you want to do?
I think the first one should be adding a stone to a board.
Okay, and then what is the change state?
The change state is that position you added to goes from like there's no stone to having a stone.
Awesome. Okay, let's do that. So write the test. What's a good test name?
So you the way according to what you like it with scenario and the result and what's the method, right?
Okay,
it
so
starts with
it's not just a method. For us, it's the unit of work. Remember, a unit of work can be something even bigger than a method. It could be whole classes. As long as it's all in memory, you should be okay.
Okay, so add stone.
Yeah.
Scenario. Well, add stone adds the unit of work and scenario right now kind of sounds similar, doesn't it?
Sure.
Add
Let's do
stone,
that. Add stone. Well, add stone. Stone is added. You mean that it succeeded?
Oh.
Under what scenario?
Stone,
What should happen?
Add. Right? Is that the scenario?
Yeah, that might be good. That position is empty. Maybe. I
And,
know that. Well, you can say to empty position instead of add stone to empty position, because you're just repeating yourself there.
Say it again.
Well, you don't have to say add stone twice. You can just say add stone to empty position.
Ah, I see. To empty position.
Yeah.
And then success or
Well, no.
position.
What is the expected behavior now? Is it position is filled or?
position. Yeah, position filled.
Okay.
Okay.
So now, before we actually write this test, now that if a position is filled, it also has a default value, right?
Right.
So we can start with an even simpler test by having
Nice.
just checking the state of a default position without doing anything.
Okay. That
Okay.
sounds very interesting.
So go just above that and see what we can do.
So I guess the unit of work would be like query position or get position.
Now the question is that what you're trying to do? Will you have a get position in the game? The get position status?
Yeah, get position status.
Or is get position status something that's internal, that's going to be used by something else? Does the user have to know the status of a position?
Yes.
Okay.
Yes.
Okay. Get position status.
Or just get position status. Or,
Okay. Now that's
empty.
interesting. Well, empty position is the expected value, right?
Right. Initial
So you can say that
initial,
initial position might be good.
initial status.
Is empty position. Okay, that's good. I think that's a better starting test.
Okay.
Okay. So
Okay,
let's
so
put the other
when
test in
we
the
do the other
comments.
one, just comment it out for now,
For
or
now,
just
yeah.
leave it there.
You can comment it out.
Oh shoot.
Don't worry, you don't just delete it. Who cares? That's why God created source control.
Yeah. Sorry, I'll just comment it out.
Okay. Now, don't forget the test attribute here. Okay, perfect. Now, if you're not sure how to run with this, you can start with the end. You can actually say, well, I know what I'm expecting, so let's start from that.
Something empty.
Are you getting back an enum or just a true false?
I was gonna, well, I feel kind of tainted from what I written before. I did an enum,
Okay.
so
Can it have more than the true false?
yeah, either white, black, or empty.
White, black, or empty in Go? Interesting.
Yeah, so there's two players, white
Yeah.
and black,
Mm-hmm.
and then if there's no stone, empty.
Uh-huh. Okay.
So I could either split in two methods, like does it have a stone or not?
Mm-hmm.
That's one method. The other stone is like what color the stone is, or I combine it in one, and it's enum of 3, right?
Whatever you want. Whatever is more readable to you.
Okay. Okay. So would I do like a board, like get position?
No, hold on.
No?
You just assume that you get back a result. Then we'll
Okay.
figure out where you get the result from.
Okay, so
Okay.
I do a result.
Exactly.
Right?
Now, hold on. Something about the way you write stone empty. I'm
Okay.
saying, what I'm thinking is that maybe stone is not a good enough enum name. It could be stone status empty.
Okay.
Okay.
Why would stone not be good enough?
Because a stone means that you're looking at a stone, not at a position.
Okay.
So it might be even position status instead of stone.
Alright. Position status sounds more clear.
Okay.
Ooh. Keep on switching it. Alright.
Okay. And so no, where are we getting the result from?
So we get the result by querying the board.
Okay. So if you had the ultimate design, assume that everything is already perfectly designed.
Right.
How would the API look like? How would you get the query? How would you get the results? Just get the result from there.
Alright. So
Do you have to have an X and Y? What's the simplest position? What's the beginning position?
simplest position might be 1.
Okay.
Because I was thinking the board goes from 1 to 19 instead of doing a 0. 0. I forget what the term. Starting from 0. Start from 1 instead.
Well, that's if you're the Go master here. It's your domain. So,
All right.
okay. So I wouldn't actually declare the position status as a result just before. I would just say position status result like this. Oh, I tried to. Never mind. Different shortcuts here because I'm running on a Mac.
Right.
Just like that. Control Shift L. Sorry.
Okay.
Okay, so position status, result, board, get position. And how are you getting the board? Do you just create a new one?
Yeah.
Okay,
Yes.
do that.
All right.
No, it's not an iBoard.
Oh, my bad.
And it's
Okay.
also in the beginning, it's not an iBoard. Just a board.
Okay, so we don't want to do. All right, you're. Okay, so we don't go with interfaces in the beginning.
You start with the simple solution that works. Okay?
Okay.
You don't have to abstract away nothing because you don't have anything to abstract. You don't have any problem.
Okay.
Okay? You let the design emerge as things go. Okay, that looks pretty cool. I also like to separate these so that it's more readable.
Right. The arrange, act, and insert thing. Right.
Exactly. And also, you'll notice that you call this get position status, but you felt more inclined to just say get position.
Right. Right.
So which one do you like better?
I like the.
Okay.
All right.
So now we can make this compile and see it fail for the first time.
Okay. So
So just make everything compiled by going to each of the red ones. Okay, and pressing Alt Enter, and generating the class right here. Don't worry about it. Okay, we can always move it later.
I see.
Okay.
What did Alt Enter do? Did Alt Enter run it? Or
Alt
just-
Enter. If you'll notice, there whenever I'm on a red thing here, ReSharper has a nice lamp here, so it tells me
Right.
possible actions for a possible problem. So it's
see.
like the genie. Just it always
Okay.
tries to help. So you
Okay.
can go to position status and generate that as well. So it's a class. No, it's actually not a class. Interesting. So you can create it as a class and then turn it into an enum, I guess.
Okay. Interesting. Oh, wow. Okay.
Yeah.
Wow, very cool.
Okay,
Okay.
now we can go on into the get position status.
Mm-hmm. Okay.
Hold on.
Mm-hmm.
You're still in here. So position status is what you want. Tab, int what?
Oh,
Int x, int y, I guess, right?
X, right.
And then tab, int y, tab.
Well, how come it adds an I next to it?
I don't know why you have an I next to it. I have no idea. Okay, and what I don't like is to have a not implemented exception, because I like to have my test fail not because of something too obvious, but I like the test to fail for something that feels like a bug.
Right.
So instead, I actually will return the wrong position status.
So let's call it black.
Okay. Okay. So now we can just still make it compile, and then we should see it fail. So we'll make it compile. Create an inner member empty.
Well, how come it's not? How come it's still red?
Hmm?
Why is it still red?
I don't know. Interesting. I don't know. Maybe
Did
just
you-
call it empty position. I don't know. See what happens. Maybe it's a special word or something.
Control Shift. Control Shift V.
What are you trying to do?
It's weird. It
Okay,
looked
we'll
like
just call it empty stone. Maybe it's just a saved word. Saved word. Like special word.
Okay.
Okay, and just remove the empty one.
Okay. Interesting. And
Or
then-
maybe empty position is better. I don't know. What do you think?
Right. You're definitely right. I was just trying. Okay.
Okay, so now we can run this test and fail. So the first time you run the test, you just let's right click on the whole project
Mm.
and run tests with testdriven.net. Okay, so if I run this, I should be able to see,
Right.
okay, expected empty but was Blackstone. And you can also see the line number,
Mm-hmm.
one fail, that's what we care about. Whenever you see this, you can also double click. So you can double click here and you have this nice marker over
Mm-hmm.
where you got to. Okay, so now we can go ahead and make this test pass in the
Right.
simplest way possible.
Right.
Okay,
We just change this, right?
that is perfect. Okay, now we can use Alt R to rerun all the tests.
Does Alt R automatically build it?
It also rebuilds it and it repeats the last action.
Okay.
Perfect. Okay, so now we have the first loop in TDD.
Mm-hmm.
Okay. Now let's go to the next test that we wanted to write. Okay, so add stone to empty position, position filled.
Mm-hmm.
Okay, so now we're going to do a state-based change because at the beginning we get we know that initial status is empty,
Mm-hmm.
but then the
Right.
initial the position is going to say that it's either black or white, right?
Right.
Okay, so just don't
So-
forget to add the test. But you know what?
Alright.
Actually, before that, let's configure the environment a bit better. I want to
Okay.
teach you another trick. So I like to use the resharper snippets to generate tests. So what I'm going to do is I'm going to copy the whole test here.
Okay.
Control C. And I'm going to go to the resharper templates explorer. And now do you see the icon for creating a new one? Like a plus?
Is it this one right here?
Yeah, new template.
Alright.
Create, click it. Okay. So now we can close this window here with Shift Escape, I think. So that doesn't work. Can you drag the window? Because I can't drag the window to the side or something.
This
The Templates Explorer window. Just drag it away. So I can, yeah, okay, perfect.
do you want to put this back? Okay. Just close it.
Yeah, now I want to write the word test here. And every time I write the word test, I want this code to appear.
Okay.
Okay. For now, I'm just going to press Control S, go back to the code, and now, if we wanted to, we can just say test tab. We get this.
Wow.
Yeah. It's not good enough yet. We want to make it a bit more generic for our taste. So I'm
Right.
going to remove the whole thing here. I'm going to replace it with $and $. That's a special keyword that says this is where the cursor is going to end up when you finished all the tabbing. But also, $, anything you put between two dollar signs becomes generic. So you can say this is the unit of work. Control S to save it. And now if I go to test and I press tab, I get this.
Very
Aha.
cool.
Okay.
Very cool.
So let's just go ahead and make the $2 signs here and say scenario and tab expected behavior, and we should be done with creating a new test for now. So Control Z. Okay. Now if you press test, we can have a nice one. So add stone to empty position. Position is filled. Tab. Okay?
Okay.
So it should be easier to write new tests from now. I'm just going to delete this one.
Very cool.
Okay. Okay?
Alright. So we'll start with the assert, Ken. Ooh. Okay, what is happening there? Oh, that's good.
Press escape. Mm-hmm. Wait a minute, which stone? How do you know it's black?
You're right. It's gonna be
Now, this is where it starts to make a little less sense.
right.
Because can you add a stone to an empty position status?
Can I add a stone? Oh, like empty position status. Well, it doesn't sound nice in code, I guess.
Mm-hmm.
It would basically be like removing the stone. You'd be setting position,
Yeah,
right? Okay.
interesting.
So
That
what do
might
you-
tell us that
so you-
maybe the design is kind of problematic.
Okay.
Maybe we need a different enum for that.
Okay. Okay.
So now you can say, well, before changing something, just say what you wish the API looked like.
Right.
So instead of position status, you can just say stone type or something. Yeah, stone caller. Awesome. Mm-hmm.
Okay.
Another type to think about is just adding the stone itself, which already has a caller and status, whatever you want.
Oh, you mean like a stone object?
Yeah. What do you think?
I think no, because the stone is not going to have much of anything else. It's just going to have a color.
Okay.
To just be.
Sure.
I mean, is that how people normally do it?
There is no how people normally do it. That's the point.
Okay.
Is that you start out with something and it needs to be maintainable later.
Right.
Okay. So add stone to position with stone color black, and I think that what you get back from get position status should be not empty instead of black stone.
Okay.
Right?
Okay.
Does that make sense?
Okay. Yeah, that makes sense.
Now the nice thing about this is that since most of the design doesn't exist yet, we can easily change it, and it's going to cost us much less. You can say filled. That's also possible. What do you think?
Feel does sound nicer. Right.
Okay, so now we get to make this compile and see it fail. Create the class and then turn it into an enum. Yeah.
Oh, I forgot the tab thing.
So just click on, yeah. Stone collar. Into X tab.
It's adding an I.
I don't know why. I have no idea why.
How do I skip that?
Just tab.
Press. I think it's just enter. Alright, cool.
Okay, just make it not do anything, right?
Yeah.
Just remove the whole line. It still won't compile because you can see all the red stuff over here, right? If you can see red, it means it's not compiling. You don't even have to try to compile it yet. If you can see red in this square, it's not going to be able to compile.
Oh,
Okay.
I see. Okay.
Okay, so let's add this one. Just filled. And
Why?
still says red?
Yeah. It's weird. Maybe it likes a comma next to it.
A comma? Let's see. No, that shouldn't be a problem. Position status filled. Not sure why. Call it filled position. Let's see. Let's see what Sharper tells us. Alt enter. Add argument name expected. Oh. No, that we don't care about that. I mean, we can say basically what it tells us. We can do that. Let's see. That doesn't make we don't care about that for now. But we can say filled position maybe. Control space. Filled position. I don't know why. I have no idea.
Alright.
Okay. So now we should be able to rerun all the tests and one of them should fail. Right?
Right.
Okay, one passed, one failed. So let's make all the tests pass in the simplest way possible.
Mm-hmm.
So what's the simplest way possible?
It would be if you're adding a variable.
Nope, that's not the simplest way.
Is that a way?
I mean, yeah, I guess so. Maybe it is.
What was what you were thinking?
Well, at the beginning, I
curious.
was just thinking of putting, yeah, but you have to save the value so that get position somehow saves it. So you can just make position status return whatever is in the variable at the top.
Right.
Okay. Okay. I think you have some extra plugins trying to add stuff. Something probably with C++.
No, it's I keep on pressing caps lock because I
Oh,
have
well,
caps
so
lock.
just yeah, you can re-enable the caps lock thing if you want.
Oh no, it's fine.
So position status will be filled. Awesome.
An initial.
Alt R. Yeah, of course. No. That's already too complicated.
That's too complicated.
Yeah, you can make all the tests pass without that, right? Do you agree?
I don't think so.
Okay.
But we'll try.
Oh yeah, I agree. That's missing. Sure. So you have to add that the default. I agree.
Yeah, because I didn't set it.
Mm-hmm. Sure.
All right.
Okay, 2 passed. Now, obviously, this is an amazing and beautiful solution. It's not good enough. But we can also refactor because we no longer need the Blackstone here, right?
Right.
We can just remove that. Let's see. Did we break anything?
Nope.
Cool. And is there anything else? Yeah, we probably need the white, but we'll take care of that when we need it. So obviously, this is not good enough, right?
Right.
And what's not good enough is that, I mean, can you put in words what you want to fix here?
Well, you give it position X, Y.
Sure.
We're only checking one position.
So we're
So
always
there is-
assuming the same position,
Right.
okay? And that's the big problem. And now the way I see TDD these days is that you start with the simplest things possible, which means that you make as many assumptions as possible. And then you remove each assumption one by one, just like peeling an onion, and each one makes the code more and more generic.
Right.
Okay? So now we can remove the assumption that we always know the position. So we can write a test with a different position.
Right.
Before we do that, we have to make the test a bit more maintainable. Because right now, we have a maintainability issue. Can you see it?
We're declaring a board every time, so we can have a setup fixture to initialize the board.
Why is it a maintainability problem?
It's a duplication. It's duplicated in both methods. Redundancy, is that the word you use?
Well, yeah, it's redundancy, but it's definitely that. But the problem is that later we can add a constructor to board, and then we'll have to fix all the tests with that.
Okay. Right.
Okay. Now I don't use setup methods anymore. I'm actually writing that on the second edition of my book. Is that I'm trying not to use setup anymore.
Okay.
Because if I use setup method, then people will have to read the test in both places
Right.
to understand what's going on.
I remember reading about that in someone else's blog.
So I refactor into a factory method instead.
I see.
Control Alt M. Let's see if that will work. Create a method. Make board. Okay.
Okay.
And the same here. Alt R. Let's see if we didn't break anything. Okay, so that's the basic stuff. It can be static for now. We don't have to do anything about that because it's part of the tests. But now I don't need a setup method, and I can see exactly where board is created.
Oh, I see.
Okay?
Okay, very cool.
Okay, so let's remove an assumption about, obviously, the position is always assumed to be the same, right?
Right.
So what we're going to have to do is we're going to write the same test with a different position, but we're going to expect an empty position.
Mm-hmm.
Do you agree?
Right.
Well,
Right.
is it going to be the same test, really?
Well, there could be. We could reuse one of the tests to do the. No, I think to get it to fail, we probably need to add a different test where we add a stone to a position, but check a different position to make sure it's still returns empty position. I'm not sure. Maybe is that answering your question?
Yeah. I'm trying to see if we can reuse this test or not. And would it be readable if we did that? Okay, you know what? Let's create another test for now and see how that looks.
Right, because if we reuse the test right now, it's still going to pass.
No, I agree. But we can add another assert. Or we can replace the assert and have a parameter to the test where we can say, add to this position, check that position. But we still want to check the original position. So I guess we need a new test.
Right.
Okay, so create another one. Or unless you want me to do it.
I want to watch you do it.
Okay, Control W, let's see if that will work. Control D. But you know what? I don't like duplication, but I'm gonna write another one with this. So add stone to what would you say? Add to empty position. Empty position. Other empty position is unaffected. I guess that's one way to think about it.
Okay.
Would you agree?
I agree. But I think this should probably be lowercase a.
Okay. Let's see. So we would have a make board. Control Alt V to extract a variable from that.
Oh.
Board add stone to position. Control Shift Space doesn't work here. Huh. Position. Is it? Oh, stone color. Stone color. Black. 1 and 1. It's almost the same test. Or get position status of 1 and 2. And Control Alt V again to get the status. And assert R equal. What do we have? We have a position status dot empty from status. Okay. Alt R. Two passed, one failed. Okay. So why don't you try to fix it now?
Okay. Alright. So is it...
Now remember, you have to fix it in the simplest way possible, so you can make as many assumptions as you want.
Okay. The first thing that comes into mind for me is just putting it in a two-dimensional array.
Okay. Sure.
or a list of tuples actually. Maybe a list of tuples is actually even simpler. So, or,
As long as it's simple and readable. We know that there are 19 rows in each vertex.
okay.
Do we? Is it 19
Yeah.
by 19?
Yeah, it's 19 by 19. I wasn't sure if that was not simple enough. It's like
I don't know.
if I made a constructor, or I mean, so, shoot. Got it.
And then what? Will everything pass now?
No. But,
Obviously, because we haven't used that.
right. I can make this incorrect for now, but I already know that it's -1.
Why is it -1?
Because I'm not doing a 0 index.
Oh,
Is that
okay.
the term? I'm doing a 1 index,
Sure.
1 through 19 instead of 0 through 18.
Then wouldn't it be position status of 20 by 20?
But then you would have 0 to 19, which would make it. I mean, the length of the board is
Okay.
19.
Who cares?
Positions.
Let's make it pass. Let's not worry about it now. You can always change it later.
Right.
Why are you setting the position status here in get
Ah.
position status?
You're right. I was not thinking clearly.
I think you should turn on the caps lock for you as well, because you keep hitting it for control. And
So
I'm not
you're
gonna.
breaking up for me. I can't.
Yeah, I'm
keep
saying
hitting
that you should enable your caps lock to be control again if you want, because I think it's hurting you.
All right. There we go.
Okay. Okay, now everything is passing. How can we make things a bit more readable and maintainable? So I would say that 19, we can make that into a const, for example,
Right.
right?
Mhm.
So we could do that. Sorry.
Oh,
You go ahead and do that. It'll be faster.
do you? How did you do that? Where you extract it out? Was it Control M?
Well, if you're not sure, you can always use Control Shift R to get a menu of what you want to do. If you want, you can just select the 19. Hold on. Escape.
Okay.
I'm pressing escape here. Of course, that doesn't work.
Yeah, I switched 3 keys around.
Control Shift R. Nope. Which key did you switch?
So I switched caps lock with Control because it's the biggest key,
Yeah.
and then I have my Control key as the escape, and I have my escape key as the caps lock.
Oh dear. That's why some of my shortcuts don't work. Okay. So anyway,
Maybe.
Control Shift R on this.
Maybe. Control Shift R.
You see, in extract method, introduce field or move to resource. Introduce field, for now. Replace 2 occurrences, obviously.
Mhm.
What will be the name of the field?
Board size.
Okay, and you can make it, private, I guess. Sure.
Okay.
Okay.
Why is it making it static?
That's the default, but I can just say private const int, and then make it uppercase.
This one uppercase?
I'm pretty sure there's an uppercase shortcut, but I'm not sure. Just F2 to rename it. Call it board size, uppercase. Let's see, x minus 1. It's always minus. I don't like this -1 thing. I have to tell you. It's kind of weird to me. It's unreadable. Now, how do we get rid of the -1? Just make sure we didn't break anything. Yeah. Forget about the implementation of the board for now. Of the array. How do we get it to -1?
I'm trying to think what's the easiest way to make it pretty.
If I don't have to use -1, I can make the board size bigger, can't I?
Yeah, but then I guess when you treat like the argument 0.
But I don't have a test for that, so I don't care. Remember?
Okay.
If I wanted to care about it, I would write a test for it. So we can do that the next after we fix make things more readable.
Okay.
Okay. Remember, I want things to be readable. So I can always check for. I mean, it's not like people can't send in x of -1 if they really wanted to, right?
Right.
And I'd still have to take care of that.
Right.
So what if I wanted to do this? I mean, for me, it just makes it more readable. Other people might not like it. But that's the nice thing. You can make decisions what your personal taste. Alt-R. Let's see what happens. Actually, we can make it still 19. Do we have to change it?
Because we don't have a test for the boundaries yet.
True. So now we can write tests for what happens. What kind of message do you get when you're outside the board boundaries? Okay? But I think that's pretty readable. So we can write a new test that says, well, if I'm adding a stone to a place that doesn't exist, we should be getting back this specific message.
Right.
But you know what? For now, I usually try to worry about these things later. So because I try to go through the happy path first. So I can say what happens when you're out of board position. Okay.
I see.
And then I can worry about it later.
Okay.
Okay. So let's move on to more exciting things. Where are we going with this? Let's get closer to what you were trying to ask me.
Okay. I don't think I understand your question.
You send me an email. How do I fake this behavior, etc. Right.
Right.
Okay. So what do you want to? Let's try to recreate your scenario. Are we close there to that, or do we need to anything else to get to your scenario?
Well, we still need to work on it a little bit, of course.
Okay, let's add a couple more features. What do you want to do next? Which feature do you want to demo next?
So I want to add enough stones in the board, and then after you eliminate a liberty for one stone, it disappears. So it would be like adding. Well, I'm not sure if that's the next simplest one, but that's where I'm trying to head towards. Right.
It sounds pretty simple. So exactly what you want to happen?
So I want to set up the board so that there's a black stone surrounded by white stones,
Sure.
and then when you add the last white stone, the black stone should be removed.
It should be removed on the next pulse or exactly after that.
Exactly when the white stone is added.
But should there be an event when it's removed? I mean, what does it mean that who removes the stone? The board?
I was thinking the game. The game removes the stone, and the board just acts dumb to it.
Sure. Okay, so why don't you write a test for that? A simple test that uses the code the way you wish that the user would use it. Right? Assume that the API is already there. You're just using it.
Right.
So write a new test with a template. Yep.
So unit of work.
Where does this all start? Is it in add stone?
No. So this would be like more a level above the just adding the stone. It would be more where the player adds the stone, where it does adding the stone and it also does checks, right?
So you want to add a stone to, you want some kind of so what I'm trying to understand is, you can still add a stone to the board and then have like an attached engine to the board that does all the thinking for you, or you can initialize an engine with the
Right.
board. It doesn't really matter.
Right.
But you're saying that the logic should be in a separate place.
Yeah.
What I'm saying is, for now, make the logic in the board and we can extract it later.
Okay. That would make it simple.
Simplest
Okay.
thing that would work.
Okay, you're right. So it would make it part of the add stone
For now, if
Yeah.
you want, yeah.
for now. Add stone scenario is eliminate liberties, or how would say.
I thought, well, don't you just surround something?
Yeah, that sounds nicer. Surround opposite color stone. So here, remove opposite color stone. What do you think?
Does it get removed or does it get replaced?
It gets removed.
So it becomes empty?
It becomes empty.
Okay.
So you did a make board. And what was the nice shortcut that you did?
Control Alt V to extract a variable.
Control V. Very cool. So this is also part of the setup. So for that. Why is this happening? So let's put it in the middle. So
You can just press Control D to duplicate a line, by the way.
oh really?
Try it.
That's interesting. Let me try that. Oh, very cool. Very cool.
And then you don't lose whatever is in your copy buffer.
Oh wow, that's even cooler. That is very cool. Okay. And then the action would be do it in your nice way.
So that's the top row.
So this would be the action that finally does the removing. right? The
Wait,
last
but
one.
doesn't his stone have 9 blocks to fill around it?
No, you only need the horizontal and vertical. Diagonals you do not need.
Okay. Okay.
Okay.
Mm-hmm.
All right.
So let's see. Okay. I would write this test a bit more clearer, where the position of 1, 2, 3, 2, 2, 1 to be left position, right position, bottom position, for example.
Okay.
See what I mean?
I'm trying to figure out how. I mean, would I add a comment to indicate that, or would I?
Well, just the X part, or the other part. Maybe a comment. I'm not sure.
So you mean like bottom? Um.
Yeah.
Well, actually, this one would be. This one would be left X, left Y. Is this what you mean?
Well, just the one that tells me that I visually can see. Where would it be? What if we just put the lines visually around? Can you make one line more to the left, one line more to the right, one line? See what I mean? We can actually position the C# code so that we visually see which line is above or to the right of which line.
Okay, that's interesting.
I want the test to be almost visual.
Wow. Okay, that's an interesting concept. Kind of like this.
Yep.
That's very interesting.
Just above it, yep.
Oh, that did not work.
Mm-hmm. Yep.
Wow.
That looks pretty cool.
It is very cool. I agree. Very
Okay,
cool.
so now I can actually scroll. As a reader of the test, I can scroll and I can see that this last one seals the deal.
Yeah.
Okay?
This definitely does make it more readable. Very interesting. All right.
Readability is one of the most important things in the test, because these tests, assuming it's a real software, they have to last for 10 years.
Mm-hmm.
5 years from now, if someone's going to read your test, they're going to see this. Okay?
Oh. Mm-hmm.
So readability is really important. And it also helps you figure out that you're in the right track with the numbers, that your test isn't wrong. Extract variable just before the semicolon. Control Alt V.
Control
Alt V.
Alt V.
Alt V, yeah, for variable.
Okay. All right. I don't know how I'm getting to double parentheses.
Yep, that's cool. Now make it compile. We're missing the white.
Right.
Okay, let's see what happens. Obviously. Okay. Now, I think that to make this possible, we have to start adding more information to each area, right? Not just position status, but the position status and the color, right? Which to me represents a stone, in a way. No?
You're right.
Or just a structure, whatever you want. But now we have to make this passable in the simplest ways possible. So let's see what we can do. Let's go to the production code. Okay. I'm gonna pause this for a second. I'm gonna take a little break, and I'll be right back.
Okay.
We're back.
Right. So, like you mentioned, we had to put in more information. But the interesting thing is that if we do the same thing we did with the position status matrix, is that checking, like if we initialize another matrix for the stone color, everything is gonna be set as one color initially, right?
Interesting. Yeah. But since it's empty, we don't care about it.
Right. So we don't care about that right now. So we just go ahead and do it first.
Well, we can do another. So you're saying just create another matrix? Why don't we just put different an object with more information in the matrix itself?
Right. So you may create a matrix of a different kind of object, object with more information, right?
Yeah. Instead of position status, we can create a matrix of stone info or something.
Okay.
What do you think?
Right. So I think that's a good idea. I think that's a good idea to head to. So would I start doing that right now?
Well, there is no right way. We can start doing that right now. Remember, the point is to make the current test and all the other tests fail in the simplest way possible. Right. So we have to make as many assumptions as we can so that we don't forget to add those tests later. Whatever, if we put in if we remove too many assumptions, if we make the code too generic, we might not feel any need to write tests for it later.
But I mean, like right now, one of the tests is failing. Should we take that out, refactor the code, and bring it back?
No. We have to make everything pass because we have the fact that the test is failing gives us focus. Okay. It tells us exactly what we're trying to achieve. So we have to make the point is here to make all the tests pass. It's not to refactor. It's to make all the tests pass.
Okay.
So whatever we have to do, we have to do. If we have to change the internal board, we can do that.
Okay.
Well, we can do many other things. I mean, we can have an extra board internally, whatever you want.
All right. Well, I think the easiest way to first make it pass is to not replace the object, replace it with the object yet, but copy and make it the stone color matrix.
Okay. But instead of position status, it takes in the
stone color.
Sure.
Okay. And then add stone position. The best way to do it for now would be
just add another line, I guess.
Right.
Just duplicate it and then change it to stone color, right?
Right.
You forgot to use Control D, my friend.
Oh. Okay.
I'm not saying that's the only way, but it's a good tactic.
It is. I agree. Okay. But that's not be enough to make that test pass.
No, because get positions. No. This is where we just have to add the calculation. Let's just add the calculation right here in the ugliest way possible. It doesn't have to be ugly, but in the just do it here. We can refactor it later. Okay.
Okay.
So now just figure out if the stone on the board, and we know which stone it is, right?
Right.
So let's figure out if that stone is surrounded.
Okay, so just using hard-coded values.
Yeah, that's an assumption we can make, and then later we can say, aha, what if it's a different stone? Okay? So making the assumption will make it easier for us to figure out the algorithm, then we can later make it more generic. That's the point as well. Just figure out for this test and all the others.
Okay. So the simplest would be most. It's gonna be interesting.
The and should be yeah, sure.
Say again?
No, I'm just blabbing away. Yeah, I think you're on the right track.
Alright.
You forgot to do an equals just before.
Yeah. Let's make it a little bit prettier.
Actually, Resharper can help you out with that.
Oh, really?
You see the pencil there? If you put split, flip. Let's see what happens to split. No.
That looks disgusting.
Okay, never mind. Forget I said anything.
Maybe it's because I didn't complete it yet. But
what's the stone location? 2 and 2? Yeah. Awesome. Yep. Awesome.
okay. But
But that doesn't make any sense. Yeah, actually, it does make sense, I guess.
I think the problem is that the initial position is probably all white, or no, is it all black? No, it's all white. You're right.
You know what's cool? Is that I think at some point we can just get rid of the other matrix.
Yeah. At some point.
I think actually a couple of tests for now. I mean, we don't have to do anything with the other position matrix if we can just check the color of the stone color matrix. Isn't that cool?
Yeah.
Cool. Okay, so we made all the tests pass, right?
Right.
Obviously not great because it's not readable, not maintainable. But we can at least go ahead now and say, okay, let's just... Oh, you have the control set to something else, right?
Let me
Hold on.
do you
Control... Oh, yeah. Control
Oops.
W. No, I can't work with this. Never mind. So what I want is to select the whole thing. Say, okay, Control Alt M extract method. Control Alt M.
It's not highlighted right now.
Oh yeah. Control Alt M.
Caps lock.
I tried with the caps lock. Okay, just extract method, dude. This is what happens when you have keys bound to anything else. Just undo. If I can't use control, I can't do anything on your machine, dude.
let me just remove the script. There you go.
Okay, let's see if I can do something now. Control Alt M. Yay! Extract method name. What would you call this whole thing?
Let's call it check neighbors.
It's not just checking. It's not just checking. It's actually removing.
Right. So removed surrounded stone.
Okay, removed surrounded stone. Cool. Now we can go ahead and say surrounded stone. Let's see, we didn't break anything. Alt R. Okay. Now let's write another test that proves that other stones can be surrounded as well. I think we're getting somewhere.
Okay.
We can make this a
So
bit... Sorry?
You want to reuse that test?
Do you know how to reuse tests?
Right, the test case.
Exactly. Okay, so let's have you used test case before?
Yes.
Okay, the difference is that this time in our test case
We have to calculate the neighbors.
no, we don't. I don't want us to calculate anything because we could have a bug, and when we are calculating things in the test, most likely you're also repeating production code, and if you get the calculation wrong, you actually be creating the bug, and then the test will pass.
So we would have to list out the x and y for all the neighbors too.
Yep, I guess so.
Okay.
Okay. So the way I would do it first is to say, just go through each of them one by one and say, I'm trying to see, maybe we should just write another test. I think it will be more readable.
Okay.
Than stuffing the whole
That's
thing.
probably the easiest way to do it. Yeah.
Oh, properties, God, so many windows. Start using Vim and less windows in Vim. Control V. Color stone 2. And here, we're just gonna change. Just figure out. Give me a different one position. I want to be able to see the difference between these two tests so that everything is just one off. Maybe just one line below. Are you okay?
What do you mean one off? Just change like a 2 to 3s?
Well, change all the y's to +1. I'm guessing. That's all we need, right?
Right.
So we would say this is a 2, this is a 3, and this is a 4, right?
Right.
And this is still
That would be a
3. And we can see them because they're right next to each other. So it shouldn't be a problem. I can figure it out. And then we have a 2 by 3.
Yes.
Alt R.
Okay.
Okay. So now here's the cool thing. We get to go to the production code and just make it a bit more generic. Remove some of the assumptions. So we can say just get this as a parameter. So I can say Control Alt P for extract parameter. Replace. Yeah, we can use six occurrences. No, just one occurrence for now.
Yeah.
X.
Yes.
And Control Alt P for Y. And now everything else is just a calculation, right?
Right.
So it will be faster if you just do all the, because I'm doing it remotely, if you just make all the differences. Whoops, we got a bug.
Alright, we need to change this to XY. But this is also still gonna fail. And then it's supposed to be check all the neighbors. Actually, this is probably gonna be more.
Wait, hold on, what?
Well, it's because
Are you just renaming it?
No, I'm not gonna rename it. I was gonna control D. Shoot. I was gonna control D. Oh, this is really, really, really ugly code.
Don't worry, just make it work. We do we really have to use all of these? We just
No.
have to figure out, just check the specific stone, don't we?
Right.
Just 2x2 or 2x3 or we have to make it work for both, right?
Right.
Interesting. But we still have a bug.
Yeah. Yeah.
X minus 1, X plus 1, Y minus 1, and Y plus 1. We didn't check the Y and X itself. You're missing just one more. Control D. Yep. Interesting. What do you think? We can also debug if you want to.
Okay, let's go with how do you debug with the
Okay, so you basically put a breakpoint, and then you go to the specific test. Actually, what I'm gonna do, I think we have a way to see multiple windows in Visual Studio at the same time, right?
Yes. You mean split it, right?
Yeah. Vertical. I want a vertical one. Yeah. New vertical tab group. New vertical tab group. Okay.
The thing is, I don't know if it opens the same file in a vertical.
Oh, that sucks. Never mind. Okay, but we still want to go to the test. We can close this maybe so we get a bit more view. Let's see. So you can go to this test and say test with, right click on it, test with debugger.
Nice, okay. Cool.
Okay, but remember, if we want is to debug a specific breakpoint, then we can just move forward until the fifth one or the middle one.
Fifth one of the middle one, right?
So I wanna do something specific. I mean, if we look at the specific test, by the way, I'm pretty sure we don't have to do everything. We always have to check just the one above. I mean, it's always we have to check with this one. We only have to check this one, right?
Right.
So we can always check the one with X and Y minus 1.
Right.
So that should be sufficient.
Right.
So maybe the test, maybe the production code is wrong. If we look at the...
We can make it simpler.
Yeah, I mean, maybe we're just getting the whole thing wrong. Simplify. Okay. I mean, what if we just remove some surrounding with X and Y minus 1?
Okay.
I mean, we already have that, but we know that this one is supposed to work, right?
Right.
And we only have to do it on this specific thing. We don't have to break here. Actually, we do. But we don't have to do it another breakpoint here. So now we can, if we just run this test. Run test. It actually passes. Interesting.
Interesting. Interesting.
Maybe we don't need to debug at all. Yeah, 5 passed. Do you see that?
I don't know how that does anything, but...
Oh, well, welcome to programming, right?
Right.
Okay, so we know...
I know why.
You know why.
Actually, no, I don't know why.
But that's the cool thing, is that because we can make assumptions, we can make small strides towards something. Now, obviously, we know that we're missing checking the other things, because if we add things in the different order,
Yeah.
right,
Right.
it won't work. So now, we get to write a test that proves that if you add things in a different order, add stone, add stone, let's say above.
Okay.
Above and surround opposite color stone, remove opposite color stone. How's that?
Right.
So now we can simply change the visual markup of the test to say, but now we can't write the test in a visual way. How's that?
Yeah, it doesn't look as pretty.
Yeah, but we can still do it in at least Control X
What you
way,
can do is, remove
This
the
way.
top one and add it
and then say,
in another line below.
yeah. Yay! I don't know why it moved the whole thing.
Possibly because the line above it.
Yeah. Okay. Okay, so now we can see 1, 2, 3, 4, and this is the fifth.
Mhm.
And now, running all the tests, Alt R should one of them should fail.
Right.
5 passed, 1 failed, and now we can just go and slowly but surely add just one more check, right?
Right.
Control D, add a Y plus 1, right?
Right.
Let's see what happens. Alt R. Yeah. Okay. You want to try the next two ones?
I still don't understand why the other one did not pass.
You know, we're human. We will never understand. We can only just assume that we're stupid and then do things simpler.
So would it make sense to just exhaust all the options?
We don't have many, we just have 4, right?
I mean, yeah, like the other 2 options.
We have to.
So-
We have to have because each one of them is basically a feature in the application, right?
Right. Right.
Sounds like you have a clicky keyboard. Are you using like a
Oh,
DOS keyboard or something?
I have a mechanical keyboard, yes.
Yeah, okay. So
It feels
now we're
nice.
adding one to the left. Left. Okay. Add stone left and surround. Okay.
So let's add this back.
Now, when Visual Studio, you don't have to make a selection. If you just want to cut the whole line, you can just press Control X with no selection. It will cut the whole line.
Oh, really?
Yeah.
Wow.
And Control C works the same way. But you should add it to the middle, remember? More to the... You should tab that line a bit.
Right.
Okay.
Okay. Well, actually, if we move this guy.
Yeah, but I want people to see that there is an empty space there.
Okay.
And where's the one to the right? Oh yeah, now it is there. Okay. Because then I had to ask, hey, where's the one to the right? Okay?
Such a huge gap in the...
Yeah, exactly. I mean, I can see that there is above, below, and to the right. And that makes me wonder, maybe this is the one to the left.
Yeah.
Okay, run all the tests. Okay,
That
one
one
failed.
failed.
Let's go ahead and...
Control D. Alright.
Perfect.
One to the left. Should do that. R. Alright.
Okay.
Now it failed.
Now we know where... Now we've learned something. Index what outside the bounds of the array.
There you go.
Now we can go and fix... I think it's the 19 thing, isn't it?
It's,
You want to debug it? Or do you know where
yes.
it's coming from?
Yeah, let's debug it. Let's try this.
But you have to debug from the test. Remember?
Right.
So it's better if you put the breakpoint in the test and not in the production, because otherwise you're gonna get there every time for each.
Oh, so you were just gonna run the whole test? I see. This is how you do it?
This is the
Debug it?
ReSharper test runner. You can do it that way as well, but you have to put a breakpoint somewhere. So where is your breakpoint?
Right.
It's right here. Okay.
Remove. It was at
Here.
add smokers. Right. Right there. Okay.
Okay.
Right.
Okay. Then debug that bastard.
Just right. Just is there a shortcut
Test
for
with debugger. Well, we can make a shortcut if you want.
Alright, we can do that later. Just want to get this. Okay. Oh. So it's the
X0 and Y is 3. X is 0.
how's
So we have an X which is a 0? Because X
That's
minus 1 is
interesting.
a 0.
wow.
Mm-hmm. Okay, so do you understand the bug?
A little bit though. The X we add to position though. How we go? Is there a way? I'm not too familiar with Visual Studio Debugger. Is there a way to back out to history, or do I have to rerun the test?
Well,
in
you
order
can
to-
go. You can see here in the call stack. You can go to where to the location of how we got here. So you
Right.
can see that this is X. It was 1.
I see.
Okay.
Mm-hmm. And then so maybe I can go to even higher in the call stack.
Mm-hmm. So we had a 1 and a 3 because we had a 2.
Right.
So
Oh,
okay. So our
see.
bug is that if we don't have to check anything that's lower than 0. That's our bug, right?
Right.
Okay.
Right. That's our bug.
Okay.
Right. Right. So how to make this pretty?
Well, we don't have to check remove surrounded stone. Yeah, we do have to check a remove surrounded stone, but only if X. Well, for each of these ifs, we actually have to check if we are lower than 0 or not,
Right.
right?
Right.
Or we can also just, you know what, the simplest thing would be to just catch all the errors. Catch an index out of range error.
All right. That's interesting, but that's cool.
Catch index out of range exception.
I've never seen it used that way, but that's very cool.
The point here is to deliver, right? If ever this becomes a problem, because sometimes, you know, it's the performance thing, we can do something about it. But usually that's not a problem. For Go games, at least, where people think for hours. Okay, run all the tests. But Alt-R won't run, it will just repeat the last action. So you have to go to the project and run all the tests, or just outside the test, just run all the projects.
So how to run tests?
Run all the tests. So you can click outside the test. We'll run all the tests in the class. Yep.
Okay. Oh, still one fail.
Interesting.
Well, we had other failed. Yeah, this is not an out exception fail. Oh, okay. Talking to myself. Let's see.
Aha.
Okay.
So it's not good enough.
Mm-hmm.
So the way I think about it is that we get an index out of range exception, but we still need to make it an empty position. So
you're right.
So we have, for each of these ifs, we actually have to check if x is, I mean, only for the ones where x is smaller than 0. For now, we can just check smaller than 0, and then we can check for all the others. Or you can just say, is x, yeah, we basically have to do each if to check is it's possible. Is there a way for an array to check if it's allowed to use a specific instance instead of checking if there is the size of x or y?
I'm not aware of any.
Then I guess it would be here. Sorry. So here we would say if x is smaller than 2. Actually, it's bigger than 1. Than 1 and... Right? But that wouldn't work. Because then for each x where it's actually not bigger, then we will always have a false here.
Right.
Aha. So that's not good enough.
Right.
So we have to have a separate if for each one. Agreed? At least for now. So we can say if x is bigger than 1 and -1, don't color this. Can we change it to an or, I guess?
No, that's not going to work. I think we might need to break. We might need to break up the if statement.
Yeah, just
in order.
Sure.
And
okay. So if x is bigger than 1 and y, well, if x is bigger than 1, then we can do all the checks for x is bigger than 1. How's that?
Right. Right, yes.
1, then we can do, what do you think? If, let's see, I'll call my x -1. Oh, maybe we can just use it as flags. Right, so we can say and equals matrix. Then surrounded on left equals true. If x is bigger than 1, and then we can say else surrounded on left equals true, right?
Yes.
So if x is on the left vertex, then it's surrounded on the left.
Right.
We can make it nicer later.
Right. So you would do that for each of the sides.
I guess so. What do you think?
I agree. You could take it out of the try statement too then.
Sure. Let's get rid of the try. And then our if would just be if
it would just be each of the positions in the and. So left surrounded and right surrounded and.
Yep. Surrounded on left and surrounded on right. On right and surrounded on top and surrounded on bottom. Right?
Yep. You need a parenthesis, so yep.
Okay, so I guess we know where we're heading.
So we need to repeat that.
Yeah. You want to try it? I think it will be faster if you do it on your end.
Alright.
And I think, yeah, and we also have to check for color white, so that's true. Yeah, so and you know what? We can make this into a method later, but let's just make it all happen right here.
Right.
Just duplicate, dude. You're copy pasting like crazy.
You want me to do a Control D instead?
Next time.
Yeah. It's very out of habit. So this would be less than 19. This would be plus. This would be y is greater than 1.
You have to make it surrounded on right, also.
Yeah. Right. This one is this one. This one's surrounded on.
We don't have to do the smaller than 19, actually. We don't have any test for it anyway.
Right. So you want to just get rid of it then? And then we'll just have
Actually, then you can just declare each one surrounded on bottom as equals true, but only if, right? If stone color. Basically, you can just declare this, right? Just change this. Surrounded on top equals
you're right.
stone color matrix.
Right. What is this?
Maybe it's a try catch thing. Just remove one.
Still failing.
Of course, because we're not done yet. We're not done yet because, let's see. Remove the stone. We have this for false. Surrounded on bottom. It cannot always be false. It has to be true at some point. Right? We're missing another one. Just the last one. Control C. The only one we care about that we actually calculate for x is on the left. So it's on bottom if it's x plus 1. Actually, no. It's x and y plus 1. And surrounded on top is x minus 1 with y. No, actually, y minus 1. This is basically what we had.
Right.
Surrounded on right. Now, if x is bigger than 1,
Right.
we have true, and else surrounded on left is true by default. Let's see. Now I killed everyone. At least we have the test to know.
I think this is supposed to be 0 right there. Same thing with here.
Oh, okay.
Never mind, it's dead.
It's dead, huh? Now this is where source control would back up and we would just undo until we had that one failing test again.
Yeah.
Let's see. Okay, let's try again. We have the surrounded one. Let's just do the whole thing here again. So we can go back to where we had some kind of surrounded on left is x minus 1 and y. And then we just get rid of the whole thing. And this is almost where we were, right?
Right.
Alt R. Should have just one failing test.
Right, but with the index out of exception.
Add stone to empty position. Position is filled. Yeah, that's the index I'm over. Now we have to check this. So we can say surrounded on left equals x equals 0.
Yeah.
Or this is white. Let's see.
Right. It's the same thing with the.
Sorry?
Same thing with the y minus 1 surrounded on top. So y equals 0. So because we still have an index out of bounds, right?
Yeah, but it's not about the other things. You think it's the other things? I mean, it's the same test. But we have 4 failing tests. So is the add to empty position, other empty, is unaffected?
Right, I think it's this part right here. If you add the y equals 0. Same thing that you did before.
Sure.
Alright, only one failed this time.
Left and surround. That doesn't make sense. Because left would have worked. Empty position, filled position. So it's either x or 0. Surrounded on right should be okay. Surrounded on bottom should be okay. So, what the hell happened?
So this one we can probably debug.
Okay.
I need debug. So is this the same test that is failing?
You just look at the name.
Right.
You can see the name here. Add stone left.
Okay. So
I'm just gonna remove this. Okay.
Which one was? Actually, it's the same. Actually, I don't know if it's this one. That's probably. So it's supposed to say true, and then the bottom one is still false. So
how is the bottom one still false?
Well, it just returned false, so it's still.
Is our test wrong? X, Y plus 1 is stone color white. Interesting. So the bottom is X and Y plus 1, right? If we go to the test, this is our test. We have this is the black stone, this is the right, this is the top, this is the bottom.
Oh, this. No, actually, no.
Yeah, this is 1. It should be on the left. It should be 2. The test is wrong. Do you agree?
No, like because x minus 1.
Oh yeah. Oh yeah. So sorry, my mistake. So it is 1. Okay, and we're checking the left of each and every one of them, but we're not checking the actual one. So maybe that's our bug, right? Because here we're checking for x and y, but we're checking all around them, but we're not checking x and y itself.
Okay.
We're not checking to the right of it. That's what I'm saying. We're not checking x plus 1.
Oh. You're right. You're right.
So we're just missing a check for x plus 1. Let's go to Control Alt L. Oh, Control L for solution. No, nothing. Interesting. Run all the tests.
Nice.
Okay. So we're getting there slowly but surely.
Alright.
So we have a
Should
test
we-
for the left. We have a test
Should
for
we
the
go
right.
ahead and still add one for the right,
Only
even
if
though
you-
we know
Only if
it's gonna pass?
you think it's gonna pass?
I think it's gonna pass.
Then let's make it fail first. Then we have
Okay.
we've added too much. Why
Right,
do you
so
think it's
remove
gonna pass?
Right.
What assumption did we not add? Did it make
So
something too generic?
So this one we added in that did not affect the previous test. I did not make the other test pass. So if I comment this one out and I add the right version,
No, first run all the tests.
okay, you're right.
Okay. Can we remove anything else, by the way? Just to see what happens.
Right.
Okay. So you can see I'm just checking our coverage a bit, see what happens. Okay. So we definitely don't need the line there.
Mhm.
Yeah, so we need another test. True. Good catch.
Oops. How did that happen? Do Control D work with this?
Yeah, it works with everything.
Nice.
Okay.
Did it paste? Oops. What did I just do?
Yeah, you just push the line to the right. That's okay. Just
Oh, okay. Let's see.
okay. Now add the one to the right.
Okay. Should fail.
Okay. On comment should pass.
Should pass. Sweet.
Okay. Okay.
Okay.
So now we're getting somewhere, I guess. Let's see. So now
we gotta refactor, right?
we gotta refactor. Well, remove stone at this place and that place and this place. What do we? Well, here is where we just extract another method and say Control Alt M, remove. Check and remove surrounded. Okay. Check stones around position and remove if needed. How's that?
Yeah, I like the last part.
Stone. Check stoned. Is anyone stoned around this position? And then we have, let's see, Alt R just to make sure. Now, do we really need the position status matrix anyway? I don't think so. We can just check if it's filled by getting the stone color.
Well, the stone only has two values, right? Stone color matrix only has two values right now.
Yeah, but it could
white
be
and
null.
black.
If it's null, you can just say that it's not filled, right?
Oh, will it be null? It's a good thing to try then.
Return. So we can say if position status of Control V.
If stone color matrix,
Yeah, we just have to replace the stone color matrix.
yeah.
return Control Shift Space. Does it give me anything? Yeah, position status empty.
Right.
Otherwise, just return. Position status. Control Shift Space. No, return. Nope, nothing. Return. Position status filled. That's it.
Alright. Give it a try.
Oh, why does it say that this will never get executed? Interesting.
It's because I'm pretty sure in an array it
So what is
treats the enum value 0. It sets it to 0, and one of them is probably set to 0, which is black.
so we can make it a nullable type
Okay.
like this, right?
Oh yeah, you're right. Something like that. Okay.
There we go. Let's see. Empty position, but filled. Yeah, we just have to change the test, I guess. No, what happened? Let's see. Assert are equal. Empty position status. What did I return? Filled. Okay. Stone color matrix. Is there anything? It's nullable. Ergo, yeah, whatever. So I'm guessing it returns filled all the time. Let's see again.
What was the error again?
Except empty, but was filled. It's never null. We can just if this value, I guess, equals null. Let's see. Oh no, the value can never be null. We can just say is null, I think. No? Has value.
If I has value, I think is a
Yeah, true. I agree. Return. Return. Empty position. Interesting. So when you fill out an array with nullables, you still get non-nullables? Interesting. I guess we can just go back to where we were. I don't care about that. Let's see. Okay, redo. Control Y. Okay, let's see. We back to where we were. Okay. Okay, let's see. I'm gonna stop here, we're gonna do another one.